Okay, so this is the first problem on the Universal Law of Gravitation homework that I gave you, and basically what we're going to do is we're going to figure out, for question number 1, how much would a 70 kilogram person weigh on Mercury? Now, here's what I want you to think about. In the past, when we found weight, we've said force of gravity is the same thing as weight in physics, and we know that the equation we've used on Earth is mass times acceleration due to gravity. Now, that's worked fine in the past. However, the problem is, in this situation, we're not on Earth. We're on Mercury, and we're looking at what the weight of the person is on Mercury, so that means we're not going to be able to use the force of gravity equation as we know it. That means instead of that, what we're going to have to do is we're going to have to use the universal law of gravitation and the formula that's associated with it. So this time, instead of Fg equals ma, we're going to say the force of gravity is equal to the gravitational constant g times the mass of the first object times the mass of the second object over d squared, and d is the distance from the center of their radiuses to each other. So let's see what we know. This tells us the mass of the first person is 70 kilograms. We also know the mass of the second, or the mass of the first object I should say, is 70 kilograms. The mass of the second object in this case is Mercury. If you go up here to Mercury's mass, you see it's 3.32 times 10 to the 23rd kilograms. And if you look at that, it's not actually quite as big as Earth's mass. And then d squared, or d, is going to be the distance from the center of their radiuses to each other. So we're actually going to use the distance that is the radius of Mercury, which, as you can see, is 2.44 times 10 to the 6 meters. So here's what we need to think about. We're trying to find the force of gravity, or the weight of the person, and we know that G stands for the gravitational constant. And if you look on your quality course sheet, you'll see that the gravitational constant is 6.67 times 10 to the negative 11th power, and then it's this funky newtons times kilograms squared over, let me back that up a minute. It's newtons times meters squared over kilograms squared. And that unit should make sense to you, because realistically what we're going to try to do is we're going to try to get our answer into newtons, and if you have a mass in kilograms times a mass in kilograms over a mass in meters that's going to end up being squared, we need our meters squared to cancel and our kilograms squared to cancel. So let's just plug in what we know. The force of gravity is going to be the gravitational constant, which is 6.67 times 10 to the negative 11th newtons times meters squared over kilograms squared, times the mass of the person, which is 70 kilograms, times the mass of Mercury, which is 3.32 times 10 to the 23rd kilograms, and all of that is going to be divided by the radius, or the distance between their centers, so 2.44 times 10 to the 6th meters quantity squared. So here's what I'd say. You can do this in a couple different steps if you want, or you can also take a minute and put it in your calculator all at one time. Remember, be smarter than your calculator, because your calculator doesn't know that you're taking the entire top multiplied, squaring the bottom, and then dividing the two. So when you plug it in, you're going to have to be really, really careful to make sure you're plugging it in correctly. Definitely would remember, if I were you, is that when you put this in your calculator, when you put 6.67 in as scientific notation, remember that you can put in the 6.67, go up and hit your second button, and then your comma, because above the comma is the little EE, and that's going to show up as a single E in your calculator, and then you can put in negative 11. And what that'll let you do is then you can immediately say times 70 times 3.32 EE 23 and it's going to read it as an exponent here as opposed to having to do times 10 caret negative 11 parentheses and all of that stuff. So I would make sure you're putting it in your calculator correctly. And then when you get done, I came up with 260 newtons. Now, here's the deal. We have 3 sig figs in this answer, so we need 3 in this answer. So the only way, really, that makes sense to get this into sig figs is to put it in scientific notation. Because this 0 doesn't count, but this one does. So 2.60 times 10 to the second power newtons. And an interesting piece to consider about this is if you would do the math, the weight of this person on Earth would be about 686 newtons. So actually on Mercury, you're weighing a little bit less, and that should make some sense because the mass of Mercury is smaller than the mass of Earth. And then if you look at the radiuses, the radius of Mercury is smaller as well than the radius of Earth. So there's some interesting things happening, but the acceleration due to gravity, or this would mean the acceleration due to gravity on Mercury is a little less, or significantly less, maybe we could even say, than the acceleration due to gravity here on Earth.